Hey guys, this is 9b, which is rules for differentiation. Last exercise 9a, we did differentiation by first principles. So that's a way you can do it, but as we saw, it was a reasonably slow way. There's definitely faster ways. Now, power rule is what we're going to be focusing on this time. I touched on the power rule in 9a as well. Hopefully it's something that you remember from last year. But I also haven't actually explained why we're trying to find the derivative or what the derivative actually does. So that's something I'm going to talk about during this exercise as well. All right, so there's a couple of examples here. There's one on the left side and there's one on the right side as well. I'm mainly only going to do the one on the left side because the one on the right is pretty much the same thing, just with different numbers. So it'll be good practice for you guys to go through it. So let's have a look over on this left side. So we've been given this rule here, this function f. It's asked us to find f dash x. Now f dash x, that means the derivative. We're going to be able to find the derivative by using the power rule, which is in this shaded box up here. Now what it's saying is, here's our original function, f of x, and we want to get to f dash x, which is the derivative. So we start off, we've got x, it's got a coefficient, it's got a power as well. This is what we have to do to it to get to our derivative. So whatever your n value is, you're going to times that n value by the coefficient. See, n times a, which is a coefficient. And then you're going to take 1 away from that power. You're just going to keep on doing that for every single term. So this rule here, this has two terms. So we're going to do it for this term and for this term as well. So let's look at this first bit. So we need to take that power, which is 2, and times it by the coefficient, which is 5. So we're going to end up having 10. And then before we put a power in here, we need to have a look, and we're going to see that it's not going to stay as 2. We need to make sure we're taking 1 away. So it's going to become 1. So x to the power of 1, you don't actually need to write that, do you? All right, so this term's finished. Let's have a look at this one now. Now, the power of x here is 1, isn't it? So we're just going to do 1 times 10, which is 10. And then remember that power here, which is 1, has to go down 1. So it goes down to 0. Anything to the power of 0 is 0. Okay, so it's 10, is 1, sorry. So it's 10 times 1. So you're going to end up having 10. Now what I explained there is how it actually works, except whenever you have just x, you can just get rid of that x. It's just going to become 10. So if this said 5x, it would become 5. If this said 100x, it would become 100, etc., etc. But that's something that you guys were doing last year anyway. Right, so I just want to look at the notation as well. So this one here, it says find f dash x. Over here, it says find dy dx. These two questions are asking the exact same thing. They're asking to find the derivative. It's just a different way that you can write it. Okay, so let's actually do this one here, except it's asked us to find dy dx. So I'm going to leave my notation as dy dx. Okay, so let's use our power rule. 3 times 1/3 is 1. So 1x, and that power needs to go down 1. So it's going to go to 2. Let's look at our next term. 2 times 3 is 6. The power goes down 1, so it goes from 2 to 1. Don't need to write that 1. Over here, we've got one of those ones where it's just x to the power of 1, so we can just turn that into 9. Now this has just a normal constant at the end there. When you've got a normal constant, that's just going to completely drop off, so we don't need to put anything else down here. So we have just found the derivative for that one. So that's a derivative, and that's a derivative as well. Now let's actually talk about what the derivative is going to do for us. Now in the last exercise that I explained, we talked about average rate of change and instantaneous rate of change. Our derivative is going to help us find the instantaneous rate of change, so the gradient at a specific point, for any point along our line. So if we want to find the gradient at this line, where x equals a certain value, you're going to need your derivative here. And let's just say we wanted to find the gradient where x is 2. What you do is you'd make x equal 2 here, and your answer is the gradient where x is 2. So that's what we're doing for this example here. This is asking us to find the gradient where x is -2. So to find the gradient where x is -2, we just substitute -2 into our derivative. So we're going to end up having -10. So we can say from this that where x is -2, the gradient is -10. So you can have a go at this one. I'm not going to do all those ones because it's going to make the video long. All right, now the next question here, it says find the coordinates of the point on the curve where the derivative is -50. Now this here, even though I keep calling it the derivative, this just means the gradient as well. So if we want to reword this question, we could just say that find the coordinates of the point on the curve where the gradient is -50. This rule here is explaining the gradient for us. I'm going to rewrite that for a second, just to set us up. Alright, now they're telling us that the gradient is -50. The gradient is -50, so we can put that -50 in there. Once we've done that, hopefully you can see that the only unknown here is x. So we're finding the x value where the gradient is -50. Cool. So our x value, or where the gradient is -50, our x value is 6. But we're not actually finished this question yet. It said find the coordinates of the point where the gradient's -50. We've found the x value, but we also need to find the y value because it's coordinates, isn't it? Now, I have a rule up here that compares x to y, and I have the derivative rule here which compares x to the gradient. Now, we want to find a y value, don't we? So we're going to have to use the one that talks about y. So this one here. Alright. Now, I want the y value where x is 6. So we're just putting in f of 6 to find out what that is. Okay, so 180 plus 60, so 240. Right, so therefore, at the point 6, 240, the gradient is -50. That's what we found out there. Alright, let's move on to the next section. Okay, when we've been working out gradients before, so for example, we worked out here that where x is -2, the gradient's -10. We haven't mentioned any angle or anything like that. With d, it does actually ask for an angle. So we've given you a formula here. So see how theta, which we'd normally use for an angle, equals inverse of tan to the gradient. So we can't really find out the angle straight away, but we can find out gradients, can't we? So it's asking for the angle that the tangent to the curve at x equals 1/2 makes with the positive direction of the x-axis. Okay, so it's just saying that, I don't know exactly what our, it's this one up here, let's just say it's some parabola. It's saying that when you've got your tangent, let's just say it's like that, the angle here, it wants to know that angle. Okay, now to work out the angle, we need the gradient. So we need to work out what the gradient at x equals 1/2 is. So the gradient where x equals 1/2 is, we just need to substitute that half into our derivative formula. So the gradient where x equals 1/2 is 15, but we want the angle, don't we? So the angle is the inverse of tan the gradient. Now you're going to need to use your calculator to find this one. And when you put into your calculator, like if you've got it set to radians, it's going to come out as a radian answer. And then you're going to have to do the catalog and then DD. And the answer that you should get is this. So 86.19 degrees. I just made it 2 decimal places. It doesn't really matter, it doesn't specify. But if a question does specify, make sure you do that specific amount. Okay, now E. Let's read through this and see what it's actually trying to ask us. So this is saying that it wants the values for x. So find the values for x where the gradient is less than 0. Find the values for x where the gradient is less than 0. Now we have a rule for the gradient, don't we? So this is pretty much an inequality. We can just sketch the graph of the gradient and then find out where those gradient values are less than 0. So our gradient rule was up here. So our gradient rule, or our derivative, same thing, is this. That there. Now if I was going to sketch that, it's going to give me this. It's pretty steep. So that's going to be, I'm just going to make this a little bit messy because it's not a special, it's not actually a question. This is just part of your working out. So it's got a y-intercept of 10 and that point there is going to be -1. What we need to realize with this graph is, yes, we're comparing x, not to y. Remember, we're comparing it to the gradient. So this y-axis is actually representing the gradient. So if we look at this specific point here, what it's saying is where x is 0, the gradient is 10. Not y is 10, the gradient is 10. So down here, it's telling us that we have a negative gradient. Up above that x-axis, it's telling us we have a positive gradient. So find the x values where the gradient is less than 0. The gradient is less than 0 is represented by this bit down here, isn't it? So that point there, your x-intercept, that's where it starts to have a positive gradient or changes from negative to positive. Okay, so we can see that the x values where there's a negative gradient, it's going to be from -infinity all the way to -1. So x is less than -1, because that's where we've got that negative gradient. Alright, now this last one here that I'm going to show you, it's going to be reasonably quick. It's just another way that you can be asked to find what the derivative is. Okay, so it might say find f dash x, it might say find dy dx. Normally it's not going to say find though. It might just give you this section and you need to know that it wants you to differentiate. Okay, now let's do this one, but we can see that there's an x there, there's an x there, and we're divided by x. So we can just change this to 9x to the power of 3 plus 3x. That's going to be a lot easier for us to differentiate, isn't it? Rather than having this fraction, it's all a part of the numerator here. So let's remember how we use the power rule. The power times the coefficient, and then the power goes down 1. The power times the coefficient, and the power goes down 1. So there is our answer, just there. And there's no exam questions for this one, so I'll just get you to go straight into these questions here.